Welcome back. Today we are going to be going through Unit 5, Lesson 4, which is solving systems of equations with 3 variables. So at this point, you should be comfortable with solving systems with 2 equations, especially using elimination. If you are not, I would go back and review that before you get too far into this lesson. So we're going to go through an example here and practice a little bit. When we are solving a system of 3 equations with 3 variables, we're going to have to find an x, y, and z value. Since we have to solve for all 3 variables, the process is a little bit different than it was with only 2. So we're going to walk through those examples here. First step, you're going to pick 2 equations, 1 and 2 or 1 and 3, doesn't matter. And you're going to eliminate one of the variables. So to start with, I am going to choose equation 1 and equation 2, and I'm going to eliminate one of the variables. When looking at those 2 equations, they're lined up nicely. X's and Y's and Z's are all lined up. So I'm going to pick a variable to eliminate. You can pick any of them. For my purposes, I am going to pick the Y variable. So to eliminate my Y variable here, I'm going to have to multiply that equation by 3 so that both equations have 3y. So when I do that, I've got my first equation, which we did not have to change. And I've got my second equation now that I'm multiplying by 3. So that I can eliminate those y's. So now I'm ready to eliminate my y values. And in order to eliminate 3y and negative 3y, I am going to add these together. So I get 5x, the y's eliminate, I get 11z, and then I have a total of 59 here. So that we call equation 4. So we've created another equation, but now it only has 2 variables. So that helps us in the next process. So we know from prior experience that in order to solve for 2 variables, we need 2 equations. So we're going to repeat that process, picking 2 different equations, but we're going to eliminate the same variable. Okay, so I am now going to pick equation 2 and equation 3, and I'm again going to eliminate the y, the same one we did last time. So rather than multiplying by 3, in order to eliminate the y's now, this needs to be multiplied by 2 this time. That way I can eliminate it. So that first equation is now 2x minus 2y plus 5z equals 26. And the second one we're just copying down, 3x plus 2y plus 4z equals 15. Now I'm ready to eliminate the y's again. So I am going to eliminate those by adding these equations together. And I am going to get 5x, the y's cancel out, plus 9z, and that is going to equal 41. And I just realized on this first equation, I forgot to multiply that 5 by 2. So I need to change this to a 10z. Hopefully you caught that before me. And that will then change this from a plus 9 to a plus 14z. My apologies. So that is actually 5x plus 14z equals 41 for our 5th equation that we've created. So equation 4 and 5 we created by eliminating one of the variables. Now I have 2 equations, 4 and 5, that are 2 variable equations, so I can eliminate with those. So we are going to take that first equation that we came up with, which was equation 4 that we wrote up above. It is 5x plus 11z equals 59. And equation 5 that we found was 5x plus 14z equals 41. Now I am ready to eliminate here. So I can see that my x's are lined up and they already have the same coefficient. So I'm going to subtract those x's to eliminate. Those go away. I've got 11 minus 14, which, whoops, it's negative 3z. And 59 minus 41 is 18. So when I solve that, I get that the z is negative 6. So we now have one of our variables. Now we take that, we plug it back into one of those original equations. So I'm going to plug it in here. I have 5x plus 14z, which is negative 6, equals 41. That gives me 5x minus 84 equals 41. So when I add that 84 to both sides, I get 125. So my x is 25. So we use that elimination to solve for two of the unknowns. So right now, if we go down to our answer place, again, I am looking for an x, a y, and a z. So right now, I know that z is negative 6, and I know that the x is 25. Last thing I have to find is that y value in the middle. So we're going to select any equation that we started with in the original ones, and we're going to plug that x and z we just found in to find it. So you can pick any of the beginning ones. I'm going to pick equation 2 that we started with just because it has pretty low coefficients. So I'm going to say, all right, the original equation was x minus y plus 5z equals 13. So I know that x is 25. I know that z is negative 6, and I'm just going to fill in the rest of the equation around it. So if I simplify there, I get 25 minus y minus 30 equals 13. And if I combine like terms there, I get that negative y minus 5 equals 13. So negative y is 18, which means y is 18. So that is my third and final variable that I needed to solve for. Okay, we're going to look at that same idea, but in a slightly different context. So we can also use this same process to write in a quadratic equation if we're given 3 points that are on that quadratic. The way we do that is to create 3 equations from those points. So you're going to plug in the x coordinate from each one and the y and use it to write a standard form equation. So when I do that for this first point, my y is 30. So it's going to be 30 equals a times negative 5 squared plus b times negative 5 plus c. So we're plugging in the x here wherever we need it. When I simplify that equation, I get that 30 equals 25a minus 5b plus c. So there's my first equation with 3 variables. My second equation, now I'm going to do the same thing. So I'm going to say negative 3 equals a times negative 2 squared plus b times negative 2 plus c. Simplifying that, I get that negative 3 equals 4a minus 2b plus c. And then finally, we just have 1, 0. So for this one, it's not quite as hard because the coefficient on each of them is 1. So I just get a plus b plus c. Because when I plug 1 in for x squared and x, it's still just 1. So I now have 3 equations with 3 variables set up. Now I'm able to write the quadratic equation. Remember that our goal is to write this quadratic equation, so we're figuring out coefficients for a, b, and c so that we can plug them back in. So we're going to use those same steps. Okay, so we're going to start by picking 2 variables that we're going to solve for. So equations, we're going to pick 2 of them. Again, it doesn't really matter which 2 you pick. I'm just going to pick the first and the second one because they both have plus c on the end, so it's going to be easy to eliminate that. So my first 2 are 30 minus 25a. Sorry, 30 equals 25a. There we go. Minus 5b plus c. And my second equation is -3 equals 4a minus 2b plus c. So those c's are ready to eliminate. To eliminate them, I need to subtract. So I am subtracting these equations from each other. When I do that, I get 33 equals 21a, and I get minus 3b. C's eliminate. Now I have to do that again with two different equations. Again, remember, I have to eliminate the same variable. So whatever two equations I pick, I have to eliminate C again. So for this one, I'm going to pick the second and third equation again. So I'm going to say the second equation was -3 equals 4a minus 2b plus c. And the third equation is 0 equals a plus b plus c. So to eliminate, I have to subtract the c. That's what makes those eliminate again. That leaves me with -3 equals 3a minus 3b. I'm down to my two equations for two variables. Now I get to solve them using any method. We're going to eliminate again. So I have 33 equals 21a minus 3b, and I have -3 equals 3a minus 3b. So I notice right away there, when I write it like that my b's are ready to cancel. To eliminate those two equations, I would have to subtract -3 minus -3 to make those cancel out. So that's going to give me 36 equals 18a. So that means that a is 2. So I've got my first variable. So again, if we're writing our solutions, we can say that the first part we have is a 2, and then we got to find the other ones. So again, I'm going to go back now and take that 2, plug it into one of our original equations. So I'm going to plug it into this one, the bottom one, -3 equals 3 times our a value, which we now know is 2, minus 3b. Solving that equation, I get 6 minus 3b. So that would be -9 equals -3b. So b is 3. So now I know that my b value is 3. All right, moving on to finding the last one. We're going to pick one of ours. Again, I'm going to pick the simplest one, so I'm going to pick the bottom equation. We have 0 equals a, which is 2, plus b, which is 3, plus c. So I have 0 equals 5 plus c, and that means c is -5. So now I have my a, b, and c values. And remember, our goal with this was to figure out the coefficients of our quadratic. So writing that equation in standard form is going to be y equals 2x squared plus 3x minus 5. Finally, we are going to practice a little bit. So I would encourage you to stop the video here, pause it, and come back when you've solved them and tried them and check your work. All right, this first one, I'm not going to go through the whole thing, but let's check your work here. So in this one, x that you should find was 4, the y should be 0, and the z should be 8. Number 2, I will go through the process here. So we have 3 equations. I need to eliminate a variable. So if I'm looking at the first 2 equations, I can notice that this very first one already has a variable eliminated, which is nice because I don't have to do that work. I already have an equation where one variable's been eliminated. So now what I want to do is I want to eliminate that same variable. So right, it's missing a y. Now I want to eliminate that same variable in these 2 equations. So step 1's kind of already done for me. Now I need to do the second equation. So to eliminate that y value in these 2 equations, I'm going to multiply that one by 2. That is going to give me 4x plus 6z equals 10. And then we have that second one that's already got the 10y. And now I'm ready to eliminate those y's. So to eliminate -10 and +10, I'm going to add those together. That's going to give me 5x plus 2z equals 18. Okay, so now we have two equations with two variables, so we can set those up to eliminate. So the first one we already had done for us, which was nice. And I'm going to put this second one we found with it. And now I am ready to solve. So in order to eliminate here, I need to multiply something. So for this one, I'm going to have to multiply this bottom one by 3. So I'm going to keep the top one the same. And multiplying that bottom one, I get 15x plus 6z equals 54. Okay, so now I can eliminate those z's by adding these equations together. That's going to give me 23x equals negative 48 equals 92. When I solve that, I get that x is 4. So we have one of them. Now I need to find the next one. So I'm going to plug back in here that x value to one of my original equations. So I'm just going to come right here and do it. 5 times 4 plus 2z equals 18. That's going to give me 20 plus 2z equals 18. When I solve that down, I get that z is negative 1. So we've got an x, we've got a z. Our last step is to find the y value. To find y, we take the x and z and plug it into one of our original equations that we started with all three variables, and we're going to solve there. So I'm going to, it doesn't really matter which one we pick, so I'm just going to do the bottom one. So I'm going to plug in my x coordinate. We're solving for y, and we're plugging in the z coordinates. So we've got that combining like terms here. I get 10y plus 8 equals 8. And then when I simplify there, I get that 10y equals 0. So y is 0. So those are my three parts. If I write my final answer as an ordered pair with three terms, it's 4, 0, and negative 1 as my final answer. For number 3, again, I'm just going to give you the answer. I'm not going to go through the whole thing, but if you solve this one, you should get negative 4 for x, negative 2 for y, and 4 for z. Okay, for our final example here, I will go through these. When I look at these, I am going to have to eliminate something here, and I notice two things. I notice that my y's are all really close right now. The only thing I need to do to start eliminating is multiplying that bottom one, but let's start with these top two. So for these top two, I have 4x minus 2y plus 8z equals 30, and I have x plus 2y minus 7z equals negative 12. So those y's are already set up to eliminate if I just add them together. So I'm going to add these equations and get 5x, y's cancel out, plus z equals 18. Okay, so there's my first one. Now, again, to eliminate with this bottom one, that y coordinate, I am going to have to multiply this equation on the bottom by 2. And again, you can pick either one. I'm just going to pick the middle one and that one to eliminate. So I have x plus 2y minus 7z equals negative 12. And now when I multiply that bottom one by 2, I'm going to get 4x minus 2y plus 8z equals 30. Now I can eliminate those y values by adding these equations together. I get 5x plus z equals 18. Now I've got two equations with two variables, so I'm going to use them to eliminate. There's my first one, and here's my second one. And what we should notice right away there is, hey, those are the exact same equation. So if I eliminate here by subtracting for the z's, I'm going to get I'm going to get 0 equals 0. And hopefully we remember that that means there are infinite solutions. So that means that all three equations here are the same. They would all graph the same way. They would be intersecting always. So there are infinite solutions to that system. We'll see you next time.